So coming up next, we've got a pretty cool talk by a fellow called Dechrai. Ben is a technologist, a teacher, he's an author, he's a presenter, and he's also a hardcore privacy nut. But above and beyond all of that, he's a passionate supporter of gigantic ideas, minds, and goals. Big thinker. As an experienced developer, he's taught and shared experience of the language since 1999, which made me about 7, including aspects to security and best practices to allow PHP apps to not only exist, but to sort of break away from that stereotype that quite often comes about with PHP of being of less substance than, say, apps written in other languages. You've all heard the stereotypes, and Ben tries to break it. He's been an active member of the Open Source Developers Club, the Linux Users Victoria, Melbourne PHP Users Club, and Barcamp Melbourne. Welcome, Ben. Thank you.
Thank you. Now, I'm on VGA. Is that working? So I've got a bit of a story to tell you first, assuming this works. Excellent. So I've got a couple of thank yous to do before I get started with the actual talk. The first person I'd like to thank is Katie, who's in the front here. She came here at 7 a.m. with me this morning to try out my laptop. I'm one of those sadomasochists that likes to run Linux on a Mac with totally open source drivers, so no NVIDIA. And most projectors, I'm not sure if you're aware, when you connect to a projector, it gives you a bit of better information about what resolutions it supports. Most of them don't actually do that. So the proprietary drivers have this huge, big, long list of resolutions, and the open source drivers don't. So that didn't work. So I decided to install the NVIDIA drivers this morning. So my laptop's currently down there without any kind of windowing interface whatsoever. I'm going to have to probably reinstall that. So Katie gave me her laptop, and I spent about 45 minutes this morning transferring the demo, because I'm a sadomasochist in that I like to do live demos. So obviously just switching a laptop is not as easy as copying the presentation over. So I got that working, and then we knew we had HDMI here. So I'd also like to thank the gentleman in the booth at the back there, who then went scurrying around the whole building trying to find an HDMI cable and trying to jam it as firmly as possible into the box down there, because we were sure it wasn't quite making a connection, but that still didn't work. So at the beginning of the previous talk, I would like to also thank Steve. Dave. I keep calling you Steve. You look like a Steve. Dave, who said, you can use my laptop. And I said, but I'm up next. Or I could do it while the presentation. So I've actually just reinstalled it yet again onto this laptop, and it is working this time, for now. The other option that I had was to actually use Katie's laptop with HDMI and do it from the back, so you'd been all just staring at a screen, and I'd been hiding away in my shelter like a virus writer would, okay? Maybe. So before I get started with the virus information, the first thing I'd like to do is work out why this isn't working and realize that I've got to come over here for the rest of my talk. I'd like to do a visualization exercise with you all. I know that you're probably getting a little bit hungry, and the sleep deprivation is probably setting in, even though it's only the start of the conference. But to start with, I'm going to invigorate you all and ask you all to stand up. Yes, I'm one of those. And now what I'd like you to do is imagine a ball. Like it could be a golf ball or a football, or it could be a beach ball. I'd recommend not anything bigger than a beach ball, but just imagine a ball and hold it in front of you. Just imagine it. Ready? And then now imagine a warmth coming from that ball. Hold it. Ready? And now I'd like you all to smile and look directly at me. Are you guys done? Yeah. Wicked. So thank you all for the standing ovation. I will now begin my talk. Right, stand up again. No, seriously, stand up again. Raise your right hand, put it on your heart. I, insert your name, follow after me, say it all together, hereby pledge to use the, come on people, the following information. Specifically, I pledge not to allow my knowledge to be used for purposes that could cause harm to myself, another individual, or a legal entity. I think you're saying the words. I understand that the penalty for failing to uphold this pledge is committing to, I realize you're going into this without prior knowledge, but writing a brainfuck interpreter in COBOL, and presenting it at a lightning talk at the next project, as a project at the next conference you go to. I take your laughter as acceptance of that pledge. Thank you. You may now be seated. So back to the beginning, going viral for fun, not profit. So when it came to writing a virus, I thought I need to work out what is a virus, how do they operate, and how do I write one? So first of all, what is a virus? Well, it's something that's malicious. It might not want to be malicious all the time. Sometimes it gets better, but most of the time it's got a malicious undertone and intent. It wants to cause pain and harm. It replicates itself, creates new versions. Does anybody recognize the reference? Dolly the sheep. So replicates itself, exact clones. I don't think that viruses, once they clone themselves, will actually die of old age early, like Dolly's clone, not child, did. It's stealthy. Can you see it? And it takes advantage of weaknesses. So it'll go into a system and it'll find anything that it knows is a vulnerability already. Most virus writers, if they're not looking at zero-day exploits, will be looking through logs of vulnerabilities that have been found in systems and try and use those somehow. But most importantly, once it's in, it needs to avoid detection. The reference there, it was very hard to get a screen cap of this as the eye is changing. That's Mystique from X-Men. Yes. So what does a virus actually do? Well, once it's in your system, it'll start stealing your resources, specifically fish. Once it's eaten all the fish and moved on to the beefsteaks, it'll then start analyzing your host environment, going around picking up information on are your patches up to date? What network drives do you have access to? Do you have direct access? Are you natted? All of this information will start collating, potentially. Then what it'll do is go around and spread itself to as far and wide as possible. It could just be within the system itself, or it could start looking at, if I've got access to a network drive, can I start infecting files on network drives? And that way you get even further. It could even go externally through HTTP to other hosts that way. So there are numerous ways that it can then start spreading itself. Then obviously you've got your virus on a system, but how do you avoid it being detected once it's there? So detection systems are for patterns predominantly. There was, when the 9/11 thing happened, I think it was the head of security for the main airport in Israel, I think, said that all these new scanners that the TSA, the guys in the US that keep the US safe, all of those scanners, he said, they're worthless. I just watch people. And this was pattern recognition. You look for things that look like it's out of the ordinary, out of place, and that's what antivirus software does. It can do things like if a new file has been placed onto a system and then it's executed and suddenly 4,000 other files change, that's probably a red flag. So it looks at patterns like that. So if you don't stand out, if you don't do anything that seems innocuous, you're going to avoid detection a bit more easily. Again, the adaptation and evolution, if you replicate yourself but you don't actually clone yourself perfectly, you change yourself slightly every time, then it's harder for that pattern matching to work. If you're going to write a virus, obfuscate it, make it hard to understand what's going on, make it really confusing. And even one step better than that is scramble your code completely and encrypt it. And then the antivirus scanners essentially need to be able to run decryption programs on your code in order to work out what it's doing. That makes it even harder. And once you've written your virus and you've obfuscated it or encrypted it and you've got it onto a system, make sure that it's benign. Don't actually do anything. The best kind of virus is one that sits on your system and doesn't do anything, because then it doesn't bother you. So it could sit there for years. And years. And take it slow. Again, back to the reference of if you modify 4,000 files at the same time, it's going to raise a flag. Maybe just do 3 at a time and just hope that the script runs quite often. So let's write a virus. I'm going to write a malicious thing that clones itself and hides. It will also change itself. It'll look for a weakness. It will spread throughout the system. I'm not going to do obfuscation. Well, yeah, I'm going to do a bit of obfuscation, but I'm also going to do encryption, public-private key encryption, just to make it even harder to work out what's going on. And then it's not actually going to do anything. It's just going to sit there and be dormant. Before I get into the coding part of this, I'm just going to do a quick, that slide shouldn't have been there, to do a quick intro on how the encryption works that we're using. So some of the keywords that you'll see in the PHP code include CBC, which is the mode of encryption that we're using, and IV, which is the initialization vector. So basically, you generate this really long random string, which is your initialization vector. Every time you start an encryption process, you generate a different IV, and that is used with the plain text to create the ciphertext, and then the following ciphertext is actually the next key. So it kind of chains along like that. And then when you come to the decryption part, it's just the opposite way around. You don't need to memorize that. I just wanted to get those terms out there. So now, can we write a virus? Good question. So what I'm going to do is bring that over here. So unfortunately, I'm also on a foreign machine, so bear with me while I struggle with keyboard shortcuts. I think that's working. Excellent. Right. And I'm also going to have to strain my neck a little. Right, step one. So what I'm going to do is I'm going to create a new file. So I've got a file here called boom.php, which at the moment I've just got. Can you hear me when I turn my head with the microphone? Excellent.
You might want to turn the pedestal around 90 degrees. Might get easy to twist your
I
head.
think that guy in the back might kill me. No? All good? Wicked. Welcome. Thank you. So I can't actually see the edge of that, but the advantage is I'm cheating. I'm using a typo that just makes me look like an awesome coder. So I've got a list of, although I do need to read the comments. I can just about see them. Okay. So without any further ado, list of comments here to set out what we're doing. What we're going to do is look for all the files that we want to infect and infect them. So I'm going to get all the PHP files. Do you love how I can type without any typos? And then I'm going to, what am I doing at the beginning there? For each. I'm going to loop through all the file names. I'm just going to shimmy forward a little without getting in your way too much there, sir. How's that for you? Excellent. It's not helping me. So I'm going to go through all the files, and I'm going to check each file by opening the file in read mode. Damn, I'm good. And then what I'm going to do is I'm going to open another file in write mode called Infected, because I don't want to overwrite the file. I want to recreate a new file. It's very hard to do an append at the beginning in PHP without loading the whole thing into memory. And if you're about to open a 4,000 megabyte PHP file, first of all, the PHP developer was insane. And secondly, you're probably going to run out of memory by running this viral script. So I'm going to open a second file. And in there, I'm going to write file infected in this way here. You know, usually I actually do the typing. It's so much easier when I can talk to you without concentrating on what words are going onto the keyboard. So that's now written in, and now I'm going to go through every line in the, it helps if I don't lose the screen. Excellent, here we are. So I'm going to write the original file into the new file. So I'm pulling the contents out of the original script, putting it into the new file, and then close that. And now I want to close the script file, close the infected file. I'm going to rename the one that we first opened to the original, just as a backup for now. And then I'm going to rename the infected version to the original version. So now the original version is the infected version. And then I'm just going to delete the original. I suppose I could have skipped line n-3. And then I need to close that. And as you can see, I started typing all sorts of things. That's what I was actually doing. It's a good look. Wonderful. There we are. So let's actually have a look at the file that I did type, and there it is. So if I now have a look, there should be another file in here called example. And if I run PHP example, it echoes numbers 1 through 9. I know, my powers are strong. If we have a look at the file, it echoes the numbers 1 through 9. Schmick. So I'm going to run this boom script that I just wrote. All right, prizes for the person who can find the typo, given that I can't see the screen. Excuse me one moment. Excuse me. You know what I'm going to do instead is, because I came prepared for a moment just like this. Always have a plan Z. I'm already up to F or something. So I've just run boom and it's done absolutely nothing. Or so I think. Now I can run example and it still executes. So by all intents and purposes, it looks like it's doing exactly the same thing as it did before. But if we actually look at the file, you'll see file infected at the top. Wicked. Step 1 to writing a virus. It's infected another system or another script. So, step 2, what are we going to do next? I'm going to start hammering on the keyboard, that's what. So, we're going to edit the file. This is the same file we were looking at before. And the first thing that I want to do is to come down here and write the virus in instead. So I don't want to just write a comment that says infected. I want it to be a virus. So let's get the cursor back. Was that the awkward tune? Right, I'm going to do something else. Obviously, this isn't working for me at the moment, so I'm going to copy .boom to boom, and I'm going to walk us through the code that I wrote. There we go. So what I'm doing instead now, does that thing work? It does, excellent. I can move around. I prefer moving around. So we're going to put the virus in instead of writing the comment infection. And we're going to pass the virus in. So we're now turning this into a function, execute, and we're passing the virus in at the top. So this now means that I can run the execute function at any time, pass a virus in, and it'll get written into any file that it can find. Now if we scroll down a little, what I've done here is, it's just skipped off the edge there slightly, but essentially what I'm doing is I'm saying load the current file and put that into the variable called virus. And because there's an open less than question mark at the top and there isn't at the bottom, because that's kind of good practice, but when I'm injecting it into a script, there's going to be the open there and the close there to make sure that there's no spaces, because otherwise you get that data was sent before headers were sent kind of thing going on. I'm going to make sure that there's no open and close by finding virus start, which was a comment at the top of the script, and virus end, and trimming it at those points. So I now know that whatever I pull in is going to be safe to put into a file without potentially causing an issue, which would then alert the systems owner to the presence of a virus. So let's boom. So now we have here, I should have showed you the example before, but it was essentially the same as it originally was, just echoing it out. And you can see the virus start is right at the top there, so it's truncated that all the way down. If I scroll down to the end, you'll see the virus end. And the original PHP code down at the bottom there. So now what we've got is a virus actually going into the system. No, not really. I'm going to try it again. Wicked. So at this point now we've got a virus, but it's plain text. And it's very easy to detect. It doesn't change itself at all. So I'm going to it's doing something, but it's not helping me. No. I apologize for the lack of entertaining factor. It's usually a lot more fun when you're doing live coding. So we've got now the encrypted virus. So what we want to do next is take that virus and actually encrypt it. The rest of the code here hasn't really changed very much at all. The only difference is that we want to make sure that it's encrypted. So if I jump down to the encrypted function, this is where that terminology that came in before is relevant. So we're going to generate ourselves a 64-character key, which we're then going to turn into a binary object, pack it together, so it's a key. That initialization vector, we need to find out what size it's going to be. So this part here, the regiondale 128, that basically means AES 128 as an encryption method. And we're using the CVC mode that I put on the screen earlier as an example. There are many different modes. CVC is just one of them. So we're going to find out, with those two factors, what is the size of the initialization vector that's required. And then we're going to create an initialization vector using mcrypt brand to that size. And then we can grab the virus that we've written, the key that we've generated, the initialization vector, pass in the two mode types, and encrypt it, and we get our encrypted virus out. That's public-private key encryption in I suppose you could compact it down to maybe 6 lines of code. It's quite cool. Because I'm going to then put this into a file that may or may not be binary, because the output of the encrypted data is going to be a big binary, messy blob. And because it might go into a system that requires it to be slightly more text-like, I'm going to base64 encode them all, before then generating my own PHP script in text. Because obviously what I want to do is return a piece of text that is a PHP script. Yeah? So I take the encoded virus, the encoded IV, and the encoded key, and then I also declare the string that needs to be run in order to decode that. Then what I say is that the that's just the end of the next line. Then I evaluate that. Eval is nasty, except when you're writing viruses, then it's very useful. That's all I've got to say on eval. I evaluate that, which will essentially take the decrypted version of this, which is all of this code. It's kind of chicken and egg, isn't it? It takes all of that code, which means that the execute function is now suddenly available because you evaluated code that was the decrypted version of this file. I didn't think it would work first time either. And then the rest of that file is exactly the same, except I've moved the virus end from the end to there, because I only want to run this the first time, because it's generated subsequent times. Everyone with me? Let's see if this works. So, example. And the example runs. And for that, I need. So luckily, I still have here a root terminal that they've kindly left me with.
RM stuff. Is it too early for questions? The first one's going to have the last one back.
Awkward. So my options now are to bore you slightly while I fix it, or to take Katie's laptop to the back and present from the back. I'm just going to see whether I can get this working. Apologies. So it's not in there. Encrypt is installed. Hints? Anyone?
Mod enable. Is it actually enabled though? Like PHP 5 mod enable. PHP 5 mod. Yeah, going and actually enabling it in the PHP 5. We go into mods available.
Oh yeah, CLI. Thanks. It's just around the corner there. And it is.
Edit any of them and add the extension equal encrypt.
No, you want the PHP 5 mod in the end. PHP 5 mod.
Go back. Next time it's a virtual machine.
And then encrypt.
Helps if I spell it correctly. Wicked. Thank you. Who was that was just talking to me? Can you come and see me afterwards? Thank you. Right, so let's have a look at example.php. Oh, look at that. So we have an encrypted virus, and we have a key, and we have an IV, and all of that, and we still have the code at the bottom. So now what I'm going to do is, if we just have a look at the files in the system, we've only got boom and example. Let's have a look at another. You can tell that I've not got the auto typer now, because I'm getting plenty of typos. Yep, you can tell I have a care factor. Right, excellent. So now if I run example, now that one's encrypted as well. Now, I don't know if you noticed, but the encrypt is called every single time a file is infected. It's not encrypted once at the top. Now, some people might say that's not very good for performance, but one of the advantages of that is that the encrypted virus now has two different looks completely. Those base 64 encoded versions are different. Pattern matching is not going to work on that. Now, you could pattern match on encrypted virus, and my tip to you is if you're going to write a virus for fun, obviously not for profit, don't label your variables encrypted virus. What you might want to do instead is randomly generate 3 strings and make sure they're unique, because that would just be awkward, and use variable names so that every time the script is generated, not only is the IV, the key, and the encrypted version of the virus different, but the variable names are also different. And in fact, what I've seen in some viruses is that the bit that says eval, they'll even generate another string somewhere else and then generate a string by picking letters out of that string to create the word eval, and then evaluating that as a variable method so that the word eval doesn't even appear in there. That's quite a nice trick. Not that I condone any of this. So, last step, before I try and break Dave's laptop even more.
Ben, just a quick one.
Yes?
It's encrypted there, but because you've got all the keys and everything, someone could easily...
Absolutely. So yeah, very good point. The private key is actually in that code. So the key part is a private key. The initialization vector is also supposedly meant to be secret. So I'm encrypting it, but I'm sharing all the information required to decrypt it because, of course, I don't want to have to log into their machine to decrypt the virus for it to run, because that just defeats the whole point. If I can do that already, I don't need to write a virus. Unless I'm just mad, which, I might be. But yes, so you are sharing all the information required. But the advantage with using that as opposed to maybe I suppose you could still use shared key encryption for that, for this to be as effective. But by using something like AES 128 as an encryption method, you're making it even harder for any antivirus software to potentially decrypt that information. Right. Do you like that? So what am I going to do this time? This time what I'm going to do is I'm going to extend it slightly more. So now, instead of just getting all the files in this directory, I'm going to get all of the editable files within any directory. Now, what you would probably do is make that slash to just see if there are any editable files on the system at all that you can edit. For my demo, I just wanted to restrict it to the vagrant www directory because it was faster, because it will actually take a long time to build up that array of files. And I've also passed in a regex at the end there to allow you to filter what kind of files you want to attack. Then what I've done is I've thought, and in fact, I'll just show you one thing. Step 3, boom. You'll notice, so this is the version that we had from the last exercise. You've got an encrypted virus there. If I go down slightly, you've got another encrypted virus there, and then you've got the original. Because I ran boom, so boom infected itself, and then I ran example, and then example infected boom. So boom was now the plain text virus preceded by an encrypted virus, followed by a crypted with a different key virus. And obviously that's not something we want to do, because if I run this file now, I'm going to get an exception saying that the execute function is already defined, because you'll get to the second eval and it'll just break. So we want to make sure that we're not reinfecting the same file twice. So what I've done in this instance here is I've just defined a virus hash, which is basically a seed, which for the purposes of demonstration is seed. I recommend using a different seed, followed by the file name, so that again, you've got a different hash per virus. Otherwise, they could use that as a mechanism of pattern detection. I read the first line out of the script, and then if that first line contains that hash, it'll skip that file. So it's not going to reinfect the same file twice. If it continues, then it'll write the checksum to the top, write the encrypted virus, and then follow by writing the rest of the contents of the original script. So this just stops us from reinfecting files. And there's the get editable files. which I won't go through too much. It's basically a recursive function that iterates through every directory given a starting point. Will match the file names based on the pattern and return a list, which is a one-dimensional array of PHP files in this particular instance. So what I need to do first, because I'm not on my laptop, is change this to slash. Is that okay with you? Yeah. All your PHP files? This is actually Dave's dev machine, and I had to disable Nginx, start Apache, and then add yet another virtual host. So this is actually this does actually have presumably PHP. I mean, that's the kind of guy you are. A lot of code that I could potentially destroy. So I'm going to make sure I don't do that by making sure I only look in the demo. Right. So what I'm going to do now is I'm going to switch over here, because infecting things by having a virus on a system eliminates the whole purpose. You need to be able to infect a system by sending it to that system. So what I did was let's open a new tab for this one. I wrote myself a gallery, because there aren't enough of those around. Now, I was actually struggling to find a suitable demo to do a, nope, not that one. This is why I have autotypers, because I can't do and talk at the same time. I tried to run a demo against an actual system. So I started with WordPress 3.5.1, which has a number of really nice remote execution attacks available on it. The downside is that most of the sites that tell you that there are vulnerabilities like this don't tell you how to execute them, which, it's probably a good thing. But it doesn't help me write a demo. So I spent about 3 days in total trying to break or try to recreate a vulnerability in WordPress. And I gave up in the end, thinking this is going to be the smallest part of the demonstration. Let's not waste time on that. And instead wrote my own gallery system. But I wanted to make sure that it wasn't going to be one of these systems that you just look at and go, well, obviously that's vulnerable. So I actually used quite a few best practice security principles. So the idea is that you can browse for a file and upload it, and it will get displayed on this page. Now, one of the first things you want to do when you do a gallery system is you don't want to allow people to upload anything other than an image, and you don't want to store those files in your doc root. So this is the main page, and the most interesting part is probably this here, which basically says go up a directory from the doc root into gallery images, find all the files, and for each of those, call a show image PHP script, pass it the file name, so that it'll display it. So we've got that middle agent making sure that it's actually an image. So let's have a look at that. So this one here will make sure that, first of all, the referrer is in the host, or the host is in the referrer, to make sure that you're looking at the gallery. That'll stop cross-linking onto other sites. Minor point, but it's a nice addition. Then it'll sanitize the file name to make sure you're not doing, I'd like to load ... etc/ password. So that's not going to happen. Then what it'll do is it'll say the file name, the sane file name, has to be appended to ... gallery images, so it's now locking it into that directory, and it's relative. And then what it'll do is it'll open the file using exif get image type and find out the MIME type. It'll then output the MIME type to the browser to make sure the browser knows how to display it, and then include the file, so that only an image can be loaded. It has to be, the right header will be sent, and then is included and returned back to the browser. Just in case that wasn't enough, the upload script also has a list of MIME types that are allowed. If a file is submitted, it'll then, again, get the temporary file, find the MIME type, and make sure that it's in the list of acceptable MIME types. It'll then also do the, I'm duplicating code. I should have probably written a function for the make sane file name, but I'm making the file name sane, and then I'm moving the uploaded file to, specifically, /gallery images /sane file name, and then I redirect the person back to the main page. So the code looks like, big hint, it's going to break, looks like it'll only accept one of 4 different MIME types, and it has to be a sane file name, or if it isn't, it'll make it sane for you. It'll push it into a certain directory, and it'll only show the person who's loading the image the image if they're loading it from the site that from the gallery site. And again, it'll force the MIME type and make sure that everything's sane. I would say that, maybe I won't say, maybe I'll ask. Hands up who thinks that this looks at first glance 100% secure? 90? Couple of hands, 90? 80? Try to put aside any bias, given you know what the talk topic is about. I'm just wondering whether this to most people would look like it's mostly secure with the, yeah. So I tried to make it look secure. Let's have some fun. So I'm going to browse for a file, and I have here a lovely picture of bread. So I'm going to select that, I'm going to upload it, and there's my picture of bread. So let's just jump back over here and go into gallery images, and you can see we have bread.jpg. So now what I'm going to do is I'm going to be a bit nasty. So going back into step 4 over here, so we've got boom.php, which is the actual delivery virus that we want to do. I'm going to copy bread.jpg into this directory. I'm now going to edit bread. The funny thing is Vim doesn't allow you to autocomplete with a .jpg. I don't know why it doesn't think you want to edit them. That's pretty. So that first line there is what tells systems, like the file command or the MIME type detection in PHP, tells it what the file is. So I'm going to leave that one intact. And underneath it, I'm just going to come down here. Am I in the right window there? I don't think I am. OK, I'm going to have to undo that because I'm breaking things. So I've just yanked the lines from the bottom file. And I'm going to paste them in here. And now I think, because I can't quite see, there's the PHP. I need to remove one line after it. And down at the bottom there, exactly there, I need to close the PHP tag. Do I get those the right way around? Wicked. Thanks for all your help. This is a great community-driven talk. So I now have bread.jpg, which contains boom.php. Let's see how this works out. Are you excited? I haven't actually tested it on this laptop yet. I'm excited. Right. Where did it go? It was in, actually no, it was in this one here, in the demo, files, step 4. Was it step 4? Where did I put it? Oh no, it was just in demo files. Thank you. Look, it even looks like bread. I'm just going to do one quick sanity check to make sure. OK, because I was in a different directory, I hadn't done the copy of the .boom. So I actually need to edit .boom. I think that was right. Nope. Excellent. Just check that bottom one. Up one. Right. Oh, thank you. Right, anybody else notice any other issues before I destroy Dave's laptop?
Dave, last chance. It's all a dummy system. I run Windows anyway. That's right, Pierre. Where are you?
Well, I think Firefox didn't like me writing into a file that had currently been selected in a browser. So let's just open that up again. Firefox just crashed, which is always nice. Right, so let's do that again. Browse into, nope, it was this one. I'm going to lose myself eventually. Bread.jpg, and it looks like bread. So I'm going to select that, and I'm going to upload it. And something went wrong. That's interesting. Let's reload that. That didn't work either. Wouldn't surprise me. So let's just go into Right, that didn't work. Error log is your friend. Ah, Encrypt.
No, you need to restart Apache after an hour.
Yeah.
There's a command I called before.
It didn't work. It's not a module. It's not an Apache module.
There's bread.
Should be extension.
That's the old one.
That's the old one. Let's try it again. No.
Module encrypt does not exist.
Ah, thank you. Is it PHP encrypt? No.
No, it's a
You need to
PHP
do
module.
PHP, etc. PHP 5 once.
That's an awesome one.
Ah,
Configuring it for the CLI version.
PHP 5. Well, I did nmod on
Yeah.
encrypt before.
Or CLI.
Is it installed?
Yeah. So basically,
Oh, of course it is installed.
Go up the way till you get to mods available. So it'll be in the PHP 5 directory, mods available, and then we have a file name off, and it'll be
Well, that looks like it should work. Would it be impressive if I told you it worked? I'll get anybody lunch if they help me out with this one. Just don't tell yourself it's free anyway. Right. Well, what I'll do is I'll skip back to the presentation and. I can get that up. Excellent. I love when it goes from the beginning. And I'll try and get it working again. If anybody wants to see it actually working, come and talk to me, because it's a bit scary at the same time as a bit fun. So, we've done all that. Ideas for payload. So at that time, basically what happened, I would have uploaded the PHP, the bread.jpg, and would have infected show image, index, and upload. So all three of those would have been affected. And then I was going to unpack WordPress installation and just run index, and it would have gone through and started infecting the whole of the WordPress installation. But the problem then is what we've got is a virus.
You show us in the code where precisely the PHP actually gets executed, because you're uploading a file, and the file should just be treated as a file system. Why is it being?
Good question. Where was the vulnerability? Absolutely. So because bread.jpg, regardless of the file name, had that line at the beginning that told it, so if in here, even though we know, let's just check that this one is an infected one. So that's got the PHP in it. Even though we know it's got PHP in it, if we ask the system what kind of file it is, it'll tell us it's a JPEG. So when PHP receives the file, it'll check to see it's a JPEG. Then what happens? Oh, there's a virus. Then what happens at this point here, when it includes the file, but because include will actually interpret any PHP in the code, it executes the PHP at that point, and that'll then start the infection process.
But have you seen people do that to show images?
Have I seen people to do that for what?
Like include image files like that?
To include image files. In an ideal world, if you're writing a secure system, you'd have done a file open read or a file get contents for that. Or read file, anything other than include. But I have seen that used for the purposes of getting past, like, for virus writing. Yeah. Does that answer your question?
Not really.
Well,
I mean, I've never seen an image gallery that used include images. Yeah.
no, but I'm doing that on purpose in order to get around the system here.
You need a vector like that to begin with.
You do, and it's surprising how many vectors there are. This is just one that somebody might have thought it was a good idea because it's like data sanitation. when you receive all this information, you think, well, it's safe, therefore it doesn't matter if I use include and I'm lazy. And there are lots of developers out there like that, unfortunately, in many languages. I'll carry on down here. So did that, who was the gentleman who, did that answer your question about the,
My question was basically,
oh.
have you seen that exact example of someone including in the wild?
Look, I couldn't say that I have or I haven't. I don't know. It would not surprise me if it was out there in the wild. Put it that way. Gentleman in the middle who was asking the question, did that answer yours?
Sort of, yes.
Okay, cool.
The thing is, people are still going to try this code on various other websites to try to get into their machine.
Yeah.
So you're not going to be able to use this on Facebook, but you'll still put some small websites take over their servers. And if
Totally.
that doesn't work, you'll change it to hit another group of servers.
Exactly. So what would normally happen is you just have automated bot systems out there that try and throw this via an automated curl request to post it to URL endpoints that it's aware of, and there would be no human intervention required. So it wouldn't really matter if 99% of the world is invulnerable to this attack, as long as there's 1% somewhere that they manage to break through. And what you might also do as part of the virus execution is just do a quick ping to say, look, I'm active, and send a ping to a server somewhere, so you can then get the IP address of the machine that has been infected, and then you know you've got a successful hit.
So Ben, are you advocating that we solve Geordie's problem of funding open source development by planting this kind of vulnerability in our code and then on-selling those vulnerabilities?
Absolutely. Yes. It was a facetious comment about using viruses in order to make money for Geordie's open source funding program, which I approve of. Right, let's see if I can get down to that slide again. How am I doing for time? 5 minutes, excellent. So yes, as I was saying, the PHP file is now in place. We've got the virus spread throughout the system, but it's not doing anything. All it's doing is it's spreading itself throughout the system. And I was talking before about being dormant or quiet in order to avoid detection. But you are going to want to have some kind of payload, because there's absolutely no point in having this script unless you just want to piss people off by taking up disk space, of which there's not very much. So we need ideas for payload. So what is the system actually going to do? So I had a think about some ideas we might be able to do. At the very simplest, you might include something like this into the script that's outside of any function, so that it just runs any time a request variable with info is sent through, and it would return PHP info, which could potentially provide some fairly interesting information. Mostly benign, not that interesting. So what about if we did something like a DDoS, and you pass in an IP address via the DDoS, and then you start a curl string, and you put the ampersand at the end so that it returns straight back to the PHP, and you execute that. So now this one machine has been given an IP address to hit as hard as possible, as many times as possible, forever, until it runs out of CPU, or the power is, the plug is pulled because the poor systems administrator's got no idea what's going on and they can't log in remotely. You could do that. You could do that as well, where you just send a request saying wipe, and it goes, okay, I'll just use that get editable files function that I had before and find every file and just delete it. Could do that. Of course, what you would most likely do is something along these lines, where you, and George, you were talking about, what was the name of your framework? Nimbus.
Oh, yes.
Nimbus framework. If we have time for lightning talks at this conference, I'd love you to give that to everybody again. Basically, no, I won't give it away. But this is the kind of thing that Nimbus would be proud of. So essentially, you basically pass in all of the code that you want to run as a parameter, and then you execute it. So you can just do whatever you want on any system ever. So in conclusion, after this rather drawn out, and I thank you again for assisting me with this presentation. It's been fantastic. In conclusion, I'd like to promote the idea of hacking. Go forth, play around. This is actually, it's not the first, but I've not written very many viruses. Not that I do it professionally, or that I boast about it often, but it's an interesting way of changing your mindset, thinking a different way, and it helps me anticipate attack vectors for actually helping security as opposed to destroying it. The most fun I had putting this together was actually getting my hands dirty. Learn by doing is one of the many learning modalities, and if that's one of yours, then just dig in and break something. I love Vagrant, because if you break it, you just delete it and start again. It takes 3 minutes to reinstall a Vagrant box. It takes 4.5 days and a lot of hair loss to reinstall an actual machine. And finally, remember your pledge. Now, before I open to questions, of which I may or may not have any time, I was actually hoping so who here has heard of OwnCloud? It's kind of like your own Dropbox system. So I've got OwnCloud running on my machine at home, and I've got OwnCloud on that phone. And I just took a photo of you all, which is now synced on my machine at home, which had this laptop been going, would have been synced down. And then I'm using a file system change script to detect new files, which then passes it through ImageMagick, skews it slightly, puts a text over the top saying, "Thank you for a standing ovation," which I was hoping to have on this slide here, but that didn't quite work. So I'm surprised I got this far. Thank you all. Any questions? The just before dinner lunch slot is always an awkward one. You want to grab the mic?
Thank you very much for your presentation. One of the questions that I have is thinking from the security perspective. Once that you have shown how to break the system, what would be your suggestion to keep as secure as possible our system? How do we check that we haven't been hacked, and that how would we prevent, or if we have been hacked, what we should be doing? What procedures do you think that is the best idea to implement?
Sure. So security, auditing, making things secure, understanding how that works is a huge topic of its very own. The idea that I hope this talk gives is that by playing with the other side, by trying to write something malicious, you understand more about how your systems could be compromised to give you more of an awareness. The comparison, I suppose, is that the security stuff is done by the developers, and this kind of stuff is done by the testers, whether that's UI testers, pen testers, any of those types. But having an awareness of both. Some of the best pen testers I know were developers for most of their previous career. So just play on both sides and get to know them both, be comfortable in both areas, and learn from that.
Does open source inherently make you vulnerable using open source libraries and...
Does open source inherently make you vulnerable? I love this question.
Yeah, I mean, if you write your own stuff, you can write security flaws, but if no one sees your code, they won't work it out. But if you use WordPress or Symfony or anything else, and a 0-day comes out, then everyone knows your flaws suddenly and can attack your servers.
I don't believe that the differences in the number of 0-day vulnerabilities found is swayed either way by a project or product being open or closed source, which suggests to me that closed source software is just as vulnerable to vulnerabilities, is that possible? Susceptible to vulnerabilities that are detected or discovered. So having access to the source code absolutely will make it easier for you to discover the vulnerability if you want to pour through hundreds and thousands of lines of code to find it. On the other hand, a lot of vulnerabilities are found through black box testing, just throwing data at a system and seeing what comes back. And the advantage to open source is that if you find a bug, then you're going to fix it. So 0 days are fixed possibly a little faster. In the proprietary world, there's a tendency to keep things under wraps so that the leak isn't too widely spread before it's fixed, which is a good idea. I mean, you've got this responsibility of disclosure thing, which should apply to both open and closed source products. But I don't see that there's a direct correlation between open source and reduced security through the source code providing direct access to that vulnerability. You'd have to be very patient to go through code and find it. And if you're that kind of person, you probably fix it, hopefully. And if one person can find it, then multiple people, for bad, multiple people can find it for good, I hope.
But I guess, I mean, like if you keep your software up to date, like your WordPress install the latest version, but you know, it's easy to tell what a particular version is at and what its vulnerabilities are. You know, you can, like you were saying, you found out what even though you couldn't find it in 3 days, you know, you probably could have got there, and then you can easily work out what servers are running that version of WordPress.
Totally, but if you look at CVE detail, Charlie Victor Echo, cvedetail.com. That's where I found lots of information on vulnerabilities that have been disclosed, and there are closed source proprietary packages listed there as well as the open source ones. So you can go in, you can find out about a remote execution vulnerability for, I don't know, IIS, and work out how to do that as well. I did completely black box testing with trying to break WordPress. I didn't look at the code to try and work out how the vulnerability might have been done. So there was, to my point, from my perspective at that point, there was no difference. Yeah. There was a question just there from the gentleman. I was going to say the gentleman in the black top, which is probably most.
I could tell a little bit about this from MySQL Marine point of view. We have, when a big company is using your open source software, actually put also security expert to check it. So we have got lots of tools run on MySQL and MariaDB just to ensure that can we trust this. Yeah. This is not done on closed source software. So I believe that open source is much more secure, A, because it's much more people using it and actually checking it, and B, some of those vulnerabilities that are found are reported first to us. They're giving us 1 week to fix it before the rest of the world get to know that. That never happens with closed source software.
No, they keep it under wraps until they can fix it, which could take months. And all that time, tons of systems around the world are still vulnerable. Anyone else? Well, if you do want to talk to me more about this, come and find me at any point during the conference. I won't keep you from your lunch any further. Thank you for your time.